Hello you 10s and welcome back to Math and Magic. Now this looks fairly familiar. Unfortunately, I'm in a bit of a predicament where I am stuck at home at the moment because of the current COVID rules, which is unfortunate. It would be lovely to see all your faces again. But here we are. I'm back in video format. Isn't this lovely? I'll be online for the next week, so next 5 lessons for you guys. So I'll be making these videos, and hopefully you'll be able to watch them during class. There will be times where there will be opportunities for you to stop the video and have a go at a few examples before you move on to the next one. So hopefully this helps with explaining a few things in the booklet. We're going to be finishing off this booklet, and there should be another one that's already printed and ready to go for our next lesson. So hopefully that should come to you shortly. So for today's lesson, we're continuing with our topic of measurement. We're looking at area of circles and sectors. So this is on page 34. So if you have a look, the learning intention and success criteria for today are that we're going to be finding the area of circles and sectors. And by the end of today's lesson, we want to be able to recall the area formula for a circle and apply it for sectors, and also apply area formulas to find areas of circles and sectors and find the area of composite shapes. So here we go. So first thing is finding the area of a circle. Now, when we are trying to find the area of a circle or dealing with circles, we really just need one measurement. So if I draw a circle, and I'm going to cheat here. Now, hopefully you guys can all pull out your circle tool from your pencil case and do this. I'm just kidding. So when you have a circle, we're really only looking at one measurement. The one over here, going from the center to the edge of our circle. If you remember from year 7 and 8, we call this the radius, and we give it the letter R for this. So here, this is my radius. And so when we're trying to find the area of the circle, the formula that we use is pi r squared. So usually we'll need to use a scientific calculator for this, so you'll probably need to grab one of those out for this lesson. We just need to take pi and then multiply it by the radius squared. Now the important thing to note here, and there's a note here, make sure that you're using the radius and not the diameter. Now sometimes a question might give you another length. If you recall, a circle also has another measurement, which is also just based off of the radius, which is the diameter. If I go from edge to edge of a circle, this is sometimes given the letter D, this is for the diameter. And we don't really want to use diameter, we just want to use the radius for all of these questions when we're trying to find the area of a circle. So let's have a go at the question, examples underneath. So, finding the area of circles. Find the area of the circles correct to 2 decimal places. So here we've got 2 examples. We're going to find the area of these circles, and we want it correct to 2 decimal places. So let's have a look at the first one. The first one, we have a circle, and they've given us this measurement, which goes from the center to the edge, which is great because that means that is the radius. Yay! We don't need to do anything to it. So here, the radius is equal to 3 meters, and all I need to do is just use the area formula. Now, if you remember from the last lesson we had, which was actually quite a few days ago, when we are using area formulas, what I recommend is to actually write down the formula first. So I'm going to write down the area formula. So here, this is a circle, so my area formula is pi r squared. Once I've done that, I'm going to substitute my value in. So I'm going to have pi times 3 squared. And so once I've done that, I can put this straight into my calculator. So here, I'm going to grab out my calculator. I'm going to put in pi times 3 squared, and there we go, 28.274. I want to round that to 2 decimal places, so this is just going to be 27.27. So here we go, equal to 28.27, and I need this in unit. I need to put a unit after this. Now the measurement was in meters, so because this is an area, this is going to be in meters squared. There we go. That's how we find the area of this first circle. Okay, cool. That's our first example done. Let's have a look at example B. Now example B, hopefully you can see that this measurement goes from edge to edge of a circle, which means it's not a radius. This is the diameter. So what we need to do first is actually find the radius from this. What we can actually do to find the radius is quite simple. we can just halve the measurement for a diameter to find the radius. So here, my radius is just going to be 1.06 divided by 2, which just gives us 0.53 kilometers. And so there we go. First step, we just need to make sure that we always have the radius when we're trying to find the area of a circle. So once again, I'm just going to write down the formula. A is equal to pi r squared. And so once we've done that, there we go. I'm just going to substitute my values in. Pi times 0.53 squared. And so we can chuck this again in our calculator. Let me just move this to the right a bit more. Ooh. Shift pi times 0.53 squared. And we get 0.88. And I'm just going to write that there. 0.88 kilometers squared. Okay. So hopefully this first part is quite simple. Now there's a few questions over the page to give you a bit of practice on this, but let's just quickly recap what we did here. When we're trying to find the area of a circle, what we really need to use is just this formula here. Area is equal to pi r squared. And so with this particular formula, we need to make sure that we have the measurement for the radius and not the diameter. If you get given the measurement for the diameter, we will need to actually halve that measurement so that we can get a measurement for the radius. And like we did last lesson when we were using area formulas, my recommendation when you do the working out, and I do want you to do the working out, I'm looking at a few of you in the classroom right now, you know who you are, do the working out. We want to firstly write the formula, then substitute our values, and then get a final answer in the third step. So when you're using those formulas, this is just a helpful way to actually make sure that we're doing the right step each step of the way, right thing each step of the way, so you can go back to your working out and go, oh, hang on, I may have missed a step here. So that's how we find the area of a circle. Have a go at the questions, and then we'll come back in a little bit, and then we'll move on to the next section where we start looking at finding the area of sectors. I'll see you shortly. Okay, welcome back. Hopefully you were able to have a chance at going through those questions where we went through finding the area of a circle. So once again, we're using that formula pi r squared. What we're looking at in this next section of this lesson is finding the area of a sector. Now, here we first got a definition for a sector. Now, a sector is part of a circle enclosed by two radii. So can I get you guys to fill this in with me? And a arc. Now, I realize that should be an arc, but Mr. Lee doesn't know how to speak English half the time, so that's fine. Now, let's talk about this. Radii, that's just a plural for radius. And an arc is actually part of a circle, which is part of the outside the circumference of a circle. So to show you this, let me draw a sector. So here, this is what a sector might look like. So here, now that's a bit fairly badly drawn, but hopefully you can see that it's actually part of and you don't need to draw this part. That's actually part of a bigger circle. And so here, a sector is just a thing, you can think of it as informally like a pie slice of a circle. So imagining a circle with a pie, we're taking a slice of a pie, assuming you're cutting it at the middle and not like a monster and cutting it out some other way. Now with a sector, let's just talk about those two parts that we've talked about in the definition. It's made up of a few things. Firstly, it's made up of two radii. So hopefully you can see we've got the center of the circle here, and we've got one radius r, and the other radius over here, a second radius as well. The length here, this measurement here, which there is a curved side, this is called the arc. An arc of a circle is just a section of a curved section of the circumference, or the exterior, or the outside of a circle. So when we're trying to find the area of a sector, how do we do this? Well, hopefully you can see that this is actually just going to be a fraction of our circle. And so what we need to do is actually, when we're trying to find the area of a sector, we need to find the angle at the center of that sector. If we have that angle at the center, I'm going to call this theta, this Greek letter I've written in the center here. If we have that measurement for the angle at the center and also the radius, we can find the area of a sector. And so the area of a sector, I've got a bit of space here. What we need to do is we need to actually figure out what fraction of the circle it takes up. And so here, this is where that theta comes in. So I'm going to first start off with theta over 360. Now the reason that is the case is because, if you remember, there's 360 degrees in a full revolution. So if I want to figure out what fraction of my circle my sector takes up, all I need to do is figure out the angle at the center, that theta, and divide it by 360. So I'm going to do theta over 360, and I'm going to multiply that by pi r squared. The same formula for an area of a circle. So here, when we're trying to find the area of a sector, we just want to find the area of the fraction of the circle that we take up by finding the angle at the center. So here, finding the area of a sector, we've got a few steps to summarize that. Firstly, we want to find the angle at the center of the sector. So find that angle theta. Then we divide it by 360, which is what that first part of this. So when we divide by 360, that's what this first part of our formula tells us we need to do. Then all we need to do as a final step is then we multiply that by the area of a circle. So that's this section at the end. So when we're trying to find the area of a sector, it's very similar to finding the area of a circle. We just need to add that additional step where we're trying to find what fraction of our circle we've actually got taken up. So let's have a go at a few examples underneath. So here we've got two sectors that we want to find. So find the area of the following sectors correct to 2 decimal places. So let's have a go at these examples. 8. So first one, hopefully you can see, this is a sector. It's a fraction of my circle. It kind of looks like a pie slice. And so what we need to do is we need to find the angle at the center, and we also need to find the radius. So if you have a look here, the angle at the center, theta, is equal to 60 degrees. That's the angle in the middle here. And the radius, like this, that is 10 meters. And so all I need to do is just chuck this into my formula. So I'm going to write that in that formula. A is equal to theta over 360. So the angle at the center divided by 360 times by pi squared. Okay. So we just need to substitute our values here. So theta, the angle at the center was 60 degrees over 360 times pi times 10 squared. And there we go. That's how we use this area of a sector formula. Find the angle at the center, divide by 360, and just multiply it by the area of the same circle. So I can chuck this in my calculator. Fraction 60 over 360 times by pi times by 10 squared. That gives me 52.359. I'm going to round it to 2 decimal places, so that will be 52.36. So 52.36, and the measurement is in meters, so that's going to be let me write the M a little bit cleaner. Meters squared. And there we go. Okay, now this is a bit messy. We'll clean that up. That's even worse. 52.36. Okay, so that's how we use the area of a sector. Okay, let's have a look at the next one. So next one, once again, find the area at the center of a circle, and then find the radius. So here for this one, the area at the center is this one over here, which is 290 degrees. So theta is going to be 290 degrees here. And the radius, well, we have it here, that's 6.8 centimeters, so that's going to be 6.8 cm. And all I need to do is just substitute this into our formula once again. So the area of a sector, A, is equal to theta over 360 pi r squared. So that's going to be 290 over 360 times pi times 10 squared. Oh, not 10. 6.8 squared. So once again, we found the angle at the center of our circle, multiply that by the radius squared. Okay, so let's chuck this again once again into our calculator. Clear that. 290 over 360 times by pi times 6.8 squared. Let me just move it across so we can see this both at the same time. So we get 117.020. 2 decimal places means that's just 02, so this is 117.02 centimeters squared. And there we go. That is our answer for this particular example here. So When we're trying to find the area of a sector, all we need to do, find the angle at the center of my sector, divide that by 360, and then multiply that by the area of a circle. So over the page, there's a few examples for you to have a look at. A few things to note: if the angle isn't stated, you might just need to think about how much of our circle is actually taken up. So for a few of these examples, the angle might not be written, but there might be a hidden angle for you to think about. So have a think about that, and we'll come back together and have a look at the next set of examples as well very quickly. I'll see you shortly. Hello again, and welcome back, Year 10s. Okay, so in the final section of our video today, of our lesson today, we're going to be looking at finding the area of composite shapes. Now, a composite shape is just a shape which is made up of multiple parts. And so, when we are trying to figure out the area of a composite shape, what we need to do is, firstly, there's a few steps here. Firstly, identify the shapes that make up the composite shape. So identify. Have a look at your shape and go, okay, well, it's made up of a rectangle here, it's made up of a triangle here. It looks like that's a parallelogram. That looks like it could be a trapezium. So identify the shapes that you have in your composite shape. Then, also, you want to find the formulas used to calculate the area of these shapes. So last lesson we looked at the area of a few special quadrilaterals and also triangles. So if you need to find and look back at those formulas, it might be helpful to do so. The final part is for you to figure out if we need to add or subtract the parts. So sometimes composite shapes are formed by adding shapes together, but there's other times where composite shapes are created by taking away one shape from the other shape. And so you will need to actually figure out which of the following are you doing. Have a look at the shape that you're given and have a look at what might be done to do so. No, make the shape. So let's have a look at two examples underneath, and I've actually told you which operation we need to do. So let's have a look at the area of the shape below. So here this shape this is example 20. Now if you have a look at the shape kind of looks like a cone. And hopefully you can see that it's made up of two parts. So I'm going to draw the dividing line right here. On the top, we have a semicircle. Nice. And at the bottom, we have a triangle. So those are the two shapes I need to find the area for. And then if you have a look at the shape and how it's created, well, it kind of looks like we just added the two shapes together. So all we need to do is find the area of each one of those parts and then add them together. So I'm just going to do my working out here. So area, well, we identified that it's actually a semicircle. So I'm going to write a semicircle. Now I'm going to use as a subscript. I'm just going to write semicircle underneath it just to be like, okay, I'm going to need to find the area of my semicircle first, plus the area of my triangle. Okay. Then from there, we just need to figure out the area formulas for each one of them. Now the semicircle is just a version of a sector. It's a fraction of a circle, so I can actually use the theta over 360 pi r squared formula. Alternatively, if you can see, actually a semicircle is just half of a circle, you could just actually go straight up, okay, this is actually just going half pi r squared, and that's cool too. Okay, plus, on top of that, I need to find the area of a triangle. Now, the area of a triangle, if you remember, is actually half base times height. That's what we looked at two lessons ago, actually. Wait, last lesson maybe. So here, all I need to do now, substitute my values in. So the first part is I need to have a look at the semicircle. So I've got half times pi times. Now I'm going to erase this so we can see it a little bit better. What's the radius of my semicircle? Well, if you have a look at my semicircle here, they tell me that this length here is 2 centimeters. That whole length, maybe I'll erase the other one, is 2 centimeters. But that's not the radius. If I want the radius, I actually only want half of that. And so for this one, the radius is just going to be 1 centimeter. So here I'm going to write here 1 square. Okay. Then on top of that, I need to find the area of my triangle. So here that's going to be half times, what's the base of my triangle? Well, the base is the same 2 centimeters over here. So that's going to be 2 times the height, which happens to be 2 as well. So here I'm going to be times 2. Okay. So once I've done that, I can chuck this all straight into my calculator. So here I'm going to put in 1 over 2 times pi times 1. Ooh, 1, oh, it's lagging a bit, that's okay, times, oh, my calculator is a bit slow at the moment, pi times 1 squared, let's see if that works, perfect, plus a half oh, it's a bit slow, times 2 times 2, and that's equal 3.57. Okay, so here we go. That's just going to give me 3.57 centimeters squared. Okay. So there we go for this first example. So for this first example, everything's starting to lag, that's okay. For this first example, we actually need to add those two shapes together to form our composite shape. So we find the area of each one and then just add them together. So unfortunately there were a few technical issues, so we're coming back to this example. So in this example, we have a rectangle and a semicircle. And if we want to find the area of our composite shape, what we actually need to do is we need to subtract the two areas. We need to take the area of a rectangle. So here I'm going to write down A is equal to area of our rectangle. And we need to actually subtract from that, or minus, the area of our semicircle. So let's write down our area formulas. Area of a rectangle is just B times H, the base times height, minus semicircle. From the previous example we saw it was half pi r squared. Okay, let's substitute some values into here. For the rectangle, the base is 12 meters by 10 meters. And for our semicircle, half times pi times, oh, let me just erase that, we don't need the meters there, times the radius. Now, let's think about our radius here. Now, on my semicircle, we get told that the length of the base here is 12 meters. So if I want the radius, I actually need to take half of that, and so that's just going to be 6 meters. So this is going to be 6 squared. So let's chuck this in our calculator. 12 times 10 minus a half. Ooh, there we go. Where are we gone? There we go. Minus a half times pi times 6 squared, and we get 63.45 meters squared. Okay. There we go. So let's just do a quick summary of what we did in this section. So in this section, we were looking at composite areas. And when we're looking at the area of composite shapes, we need to figure out what type of shapes make up our composite shape. Once we figure that out, we identify the formulas and then we write them down and then we substitute the values in and decide whether or not we need to add or subtract our shapes. So over the page, there's a few examples and a few questions for you to have a go at for homework. But until next lesson, year 10, I'll see you via video again, I guess.